Hello everyone and welcome to this exciting video. I'm going to take us through a journey of no-code artificial intelligence. Yes, you heard me right. We will solve simple AI problems without writing a single line of code. First, I'd like to thank you for joining this exciting journey, and I hope you find it exciting, inspiring, and overall fun. My name is Adewale Adesina. This is Hector, our AI virtual assistant, and if you like, bodyguard. Okay, Hector, say hello to our distinguished audience. Never mind, the machine is still learning. This video is the first part of two series where we'll carry out practical tasks with AI tools to solve problems in higher education as teachers and researchers. Specifically, we will examine how to use machine learning in our work. We will build practical AI project that harnesses the power of machine learning without the intimidating mathematics or Python code. This should be done in a fun, easy, and practical way. So let's begin.
This is lesson 6 of the VIGBE course, the ABC of Artificial Intelligence. The topic for this lesson is No Code Required, AI Tools for the Higher Education Teacher and Researcher. Now, the field of artificial intelligence sounds intimidating on its own, but we'll find out after this lesson that actually anyone can participate in one level or another. So in this video, we'll examine what is no-code AI and what it is not. We will review some AI and machine learning concepts. Next, we'll go through some simple steps for building no-code AI machine learning models. After this, we will carry out a practical machine learning project with no-code AI tool known as Google Machine. Lastly, we will look at some AI initiatives in Africa. Let's begin by reviewing some common AI applications we know of today. The first one is the Facebook facial recognition system and auto-tagging feature. Now, without explicitly telling the computer, a machine learning model is able to identify people on Facebook and put name tags on them. Siri and Alexa is another application that uses machine learning for voice recognition. It can listen and respond to voice commands very easily. The next one is the spam filter that we use every day in our mailbox. The spam filter uses AI that recognizes junk emails and sends them to the junk folder, while the good emails are sent to the inbox. A big one is e-commerce recommendation systems like Amazon, Jumia, and the likes. Based on your previous purchasing behavior, machine learning models are able to recommend new products that you may need with stunning accuracy. This is AI working. Then there is the self-driving cars and autonomous vehicles. These are vehicles that operate effectively without a driver. Someday we'll no longer need to apply for driver's license. You just buy an autonomous vehicle and it will get you wherever you need to go. Usually, these AI applications require writing lots of codes, Python codes. But with no-code AI, you don't need to write your own code. Some very smart AI engineers have written codes for us, and we only get to use these tools. So what is no-code AI? No-code AI refers to platforms and tools that allow users to build, deploy, and oversee artificial intelligence and machine learning models without requiring conventional coding skills or extensive expertise in data science. So it is part of the broader movement towards making technology more user-friendly and empowering individuals like you and me to develop sophisticated systems with limited coding abilities. So we have looked at what no-code AI is. Now we want to look at what no-code AI is not. Now, no-code AI is not a complete replacement of deep technical expertise. It is also not unlimited in scope or capabilities. It's not a one-size-fits-all solution. It's not without data requirements. Lastly, it is not independent of technical oversight. The beauty is that no-code AI helps us to appreciate and use artificial intelligence. Let's now review some basic concepts in the course. You will recall the Facilitator General in Lesson 3 took us through artificial intelligence associated terminologies and technologies. Now we learned that AI is an umbrella term that covers a domain where human intelligence, such as decision making, text processing, visual perception, and the likes, are simulated by machines. We also saw that machine learning and deep learning are subsets of artificial intelligence. Now there is a definition of AI that I particularly think is relevant here. That is, AI is simply computer programs that learn from data. You see, it's all about the data. An AI algorithm, it's a collection of rules or instructions that is used by the computer to learn from data. Now this takes us to machine learning, which is simply the ability of the computer algorithms to learn from data. So again, you see, it's all about data. AI is about learning from data. Let us explore a variety of AI tasks widely used in different disciplines, industries, and applications today. The first is classification. Think of it like sorting things into labeled boxes or categories. For instance, deciding if an email is spam, that it should go to a spam folder, or not spam, meaning it should go to the inbox based on its content. That is classification, separating into categories. Another is prediction. Prediction is like forecasting future events or values based on historic data. With machine learning models, we can predict things like what the stock market will do next, or we can look at tomorrow's weather based on features such as temperature, humidity, and wind speed today and historic data. Clustering is another one. This is the organization or collection of items so that those within the same group share more similarities with each other than with items in different groups. Now, clustering is frequently applied in dividing markets into segments or analyzing patterns within social networks. Other tasks include regression, recommendation, and generation. In the past lessons, we saw how the large language models like ChatGPT, Gemini, and Copilot generated new text information based on text prompts entered into their chat window. This aspect of AI is called or is known as generative AI. Now there are three essential requirements for AI applications. The first is data. Data is king. This includes text, images, audio, and video. To do anything in AI, the data must come first. The next is the model. This is like the brain that does all the work. We'll talk more about the model shortly. The third is compute. AI compute refers to the processing power and resources needed to train and run artificial intelligence model. It encompasses things like the hardware, GPUs and CPUs, specialized accelerators and the likes. It also encompasses the software that enables complex AI calculations and data processing at high speeds. Now let's go back to the AI model. The model is like the human brain. The human brain consists of billions of neurons that communicate to each other using electrical and chemical signals. This enables us humans to see, feel, and make decisions. Now, a machine learning model is like that human brain, but it uses mathematics and equations. The model receives the input data and processes it using deep and hidden layers, and then produces an output. An example of this is the artificial neural network, ANN. These networks are capable of learning from data, which means they can improve their performance on the tasks they do, such as image recognition, language translation, decision making over time as they get exposed to more data. So, a machine learning model is a program that can find patterns or make decisions from a data set it has not seen before. For example, in natural language processing, machine learning models are capable of understanding and accurately identifying the purposes behind sentences or word combinations that they have not seen before. In image recognition, machine learning models can be taught to recognize objects. It can distinguish between, for instance, cars or dogs. Before a machine learning model can perform its work, it has to be trained with a large data set. Now, some examples of machine learning models or algorithms are linear regression, decision tree, random forest, and XGBoost. Actually, these terms are for computer scientists and AI engineers. But let us look at machine learning techniques. So these are techniques used or utilized by machine learning. The first is supervised machine learning. Here, human beings are involved. It is like teaching a computer using a complete answer key. You give the computer examples, that is the data, where you already know the answers. The computer learns from these examples and uses what it learns to make predictions or decisions about new, unseen examples. In unsupervised learning, the human is not actively involved. It's like letting a computer sort a mixed bags of toys into groups without telling it what the groups should be. The computer looks at the toys and tries to group them based on similar characteristics, all on its own, without examples or answers provided in advance. The third machine learning technique is reinforcement learning. Reinforcement learning is like teaching a computer to play a game by rewarding it for good moves and penalizing it for bad ones. Over time, the computer learns how to make better moves and improves its game, figuring out strategies on its own using trial and error. Today, many useful AI platforms and tools are released as third-party AI tools. Third-party AI tools, these are software applications or platforms developed by external vendors. These tools offer specialized AI capabilities such as natural language processing, image recognition, machine learning model development, and many more. Some of these tools are released for free, while with others, you have to buy licenses to access and use them. Now let's look at some no-code AI tools. These tools can enable us as educators and researchers to work with AI without writing codes. If you want to work with image recognitions, for instance, you can use tools like Levity and teachable machines. You can check them up. For voice and text, you can work with Monkey-Learn, IBM Watson, or any of those on the list. If you work a lot with mainly numerical data, you can consider using tools like Accio, Data Robot, or any on the list. For our project, we'll be using the Google's teachable machine. Now, the teachable machine was originally launched by Google in 2017 as a project to democratize machine learning. Google Machine is a web-based application that simplifies the process of building machine learning models, making it quick, straightforward, and available to all users. The web address to access it is on the screen. Now let's look at steps for implementing machine learning. Then we will use teachable machine to implement these steps. The first step is defining the problem or the value proposition. Here we identify the core issue we aim to solve or the specific value that we want to deliver, whether it's predicting a customer behavior, automating a task, or making a decision. This step sets the direction for our project. Moving to step 2, it's all about the data. Data is the lifeblood of any machine learning model. We focus on gathering relevant data sets and then meticulously prepare this data. This involves cleaning the data to remove inaccuracies, handling missing values, and organizing it in a format that the algorithms can process effectively. It is important to note that the quality of our data directly impacts on the accuracy and reliability of our classification or prediction models. Next, in step 3, we bring our data to life through model training and testing. During this phase, our chosen algorithm learns patterns from the data. It creates a model that can predict or classify. After training, we test the model using separate data sets and check whether it's performing as we want. This step is crucial. It helps us to understand the model strength and where improvements are needed. Finally, step 4 is where our model goes to work. We deploy the model into real-world environment where it begins to fulfill its purpose, whether it's within an app or on our website. Now let's work on a practical project. Here we will build a smart pet gate using machine learning. Here is the value proposition. Our university requires a dependable pet identification system to effectively manage and monitor our pets. We want to launch a machine learning model that accurately distinguishes between cats and dogs, offering a useful tool across our research laboratories, or even pet owners can use it, or animal shelters, or even wildlife tracking initiatives. This is step 1, our problem definition. Next, we get to our data. So we look for several images of dogs and cats, which will feed into the machine learning model. This model will now work on it to tell us when it sees a new object, whether it's a cat or it's a dog, and then maybe activate the gate to open or close. So this is how it is implemented in Google's teachable machine. It's a very simple tool. You upload your images, you train the model, and then you test to see if it is working. So this is the website for teachable machines. Now let's see how it's done practically. So here we are at the website teachablemachine.withgoogle.com. So as you come to the website, you immediately see it's called Teachable Machine. Train a computer to recognize your images, sounds, and poses. So meaning if you have data for images, or you have sound data, or even pose data, you can use any of these in this tool. So try to go through some of the documentation here. They are really super helpful. To start, just follow Get Started. So when you are here, after clicking Get Started, it asks you want to create a new project, you want to open an existing project, or open an existing project from File. So what we want to start a new project. And is it going to be an image project based on the data we have? Or is it going to be an audio project or a polls project? We are working in this case with an image project. So simply select image project. Then you have a pop-up that asks you a standard image model and some guide for how to use it. So let's simply click standard image model. Then you come to this interface that asks you to define the different classes that you want, and then you train the machine learning model, and then you can preview, export, and deploy the model. So let's start first by putting in our different classes or categories. So I want to have cats. So that's my first. Then the second is dogs. Now, if you have other classes like donkeys, gorillas, and all, you can add them if there are more pets that you want to work with. So the next step is to get our data. So I'm going to get pictures of cats and dogs and feed them into our different categories to be able to train this machine learning model to differentiate between cats and dogs. So let me bring out my data. I've actually collected some pictures of dogs and cats. So I just did about 10 or 12 of each. So you go about sourcing your data from different places that you can get them. So in this case, I want to upload my data. So I'll start by clicking on upload. So here it tells me for my cats, I can import the images from Google Drive or from somewhere. Since I have them here, I will just look for where the cat data is and put them. So I have pictures of cats. So these are pictures of my cats. So I'm just going to select all of them. And put them on the model. So you can see these 12 images have been loaded. Next, I go for the dog images. Okay, so I go to my dog labels and choose upload. So right now I'll get the pictures of the dogs that have been collected. So you can see the dogs are in different poses, different shapes. I'll just drag it down just like I did the cats and put it there. So within a short while, you can see that the dog images also have been uploaded, 12 samples of them. You can literally train your model with thousands and thousands of data so that it behaves accurately. So after uploading your data, the next thing you can do is to train the model. So click on train model. Then you get the information, prepare training data. It does that on its own. When it's done, it tells you your model has been trained. Okay, so we are done just within a few minutes. So I'm going to be working with images, so I'll just switch from my webcam and then go directly to file. And of course, if I can use a webcam as well to acquire the images, but just to make life simple, I will just go ahead and switch to file. So now I want to test my model. So I can choose an image from my data, any image, a new one. So I actually have a file here called test data. So I can pick any sample I have from there. For instance, this is a dog. So I can drag this dog and check it to test, and of course it's telling me it's 100% sure that this is a dog. I can try with a cat. Let me just drag it there. Okay, it tells me this is 97%. It's sure it's a cat, 97%. This is quite accurate. I can do more testing. Now, sometimes you don't know whether something is a cat or a dog. You can just try with different. Let me try with a human being here that has a donkey and see what it will predict it to be. So if I drag this image here, okay, now this is funny. It's telling me it's 86% sure this is a cat. Anyway, you get the picture. So it's not having enough data to be able to process this effectively, so it's giving this kind of information. You can try and see how it behaves in your setting. Now that we are done with training and testing, we can now deploy this model and use it for our smart gate. So to do that, you just come over to this section, export the model. And there it tells you, okay, how do you want to get it done? Simply just leave it on the selection, upload shareable link, so that you get a link for your model, and then click on upload model. So what it will do is it will upload your model to the cloud, and it is ready. So you have this link, teachable machine with Google link, and then this data. So you can copy this link and you have your model ready to be deployed. You can also select and download your model so that you keep a copy and use it in a different place. So I'll just download my model and keep it for safety. So after doing that, you can now come to a different page and see how your model looks like. Here it is, and again I go to file, and then I can test this model. I can share it with people, and I can connect it to a device, and then I'm ready to use this model. So that is it. We have seen machine learning in operation. Believe it or not, we have created an AI-based smart pet gate. And the link of my endpoint is here, and it can be used immediately. The late Afrobeat legend Fela Kuti released a song some time ago that rings true today with AI. He said, "Teacher, don't teach me nonsense." Machine learning works that way. Machine learning works with data, and we are the teachers. The data we feed into these models to train them determines how they behave. If not done comprehensively and totally, there can be big problems. I think it was in 2018 when Facebook apologized after AI puts primates label on video of black men. So what happened was the AI was not able to distinguish between a black man and a gorilla. So, and this was because it probably didn't have enough data about black men. Now, according to Guardian, 6 years ago, Google had to ban the word gorillas in some of its AI projects because of accidental algorithmic racism. So AI programs can exhibit racial and gender biases, researchers have revealed, and that's why it's important to train the AIs with proper data and remove any biases. The outputs from AI, they are not perfect, but they are teachable machines. Now let's look at a case study of the development and use of AI by African scholars. The focus organization here is called Alt-I. Alt-I was established in Nigeria in 2002 to develop essential human capacity needed to generate ICT resources for African languages. Altai was established in Nigeria in 2002 to develop essential human capacity needed to generate ICT resources for African languages. Now it sought to increase the relevance of technology in African languages so that it can have presence in the global space. It's a non-profit organization located in Ibadan. The founder is Dr. Tunde Adewale, and he engages in research and development in many areas in AI. Of interest to me is this Yoruba keyboard. Still on African languages, there's a project called Masakani, which seeks to bring researchers across Africa to build and promote natural language processing research in African languages. So the aim is to reduce language barriers and foster access to information, especially regarding African culture and languages. You may want to participate in this project by visiting their webpage. Now let's get back to the task of the week, which is practical 6. What we need to do is to create a machine learning model for a classification problem of your choice using Google Teachable Machine. So try and come up with a project card like this, that is stating the goal of the project, the tool that you will use, and the practical real-world application of the project, the data you will need, and then some reflection. I actually have a Word document that presents this. This document shows example applications that can be done with Google's Teachable Machine. For instance, in agriculture, you can do pest identification. You can train a model to recognize and differentiate between various insects, including those that are beneficial to crops and those that are harmful. A lot of these projects, these are just ideas that you may want to look at. Using the POS structure there, you can train a model to understand sign language, which can then be used to teach or communicate with hearing impaired students. Still in education, a machine learning model can be developed to implement facial recognition and automate attendance recording in classrooms. So these are many other examples that you may want to look at. Medicine is a big user of AI models, and in fact it's one of the strong justifications for developing and using AI today. So now coming to practical 6, this is what is required of us. Create a machine learning model for a classification problem of your choice using Teachable Machine. So provide a project card like this. Have a topic. For instance, the project we just concluded, build, train, test and deploy an AI model to detect cats and dogs. Okay. Now this is the value proposition, the data. This is the endpoint deployment link. But we also like you to provide some reflections about this project. In not more than 200 words, reflect on your experience. You may want to describe or explain, was the objective of the AI project clearly defined? Reflect on the process of collecting and preparing your data set. What were the challenges in obtaining balanced, diverse, and sufficient data for your project? What were the most significant challenges encountered during the project? How were they addressed? And what alternative solutions could have been considered? Next, talk about or reflect on the accuracy and performance of your AI model. Were the results satisfactory? How did the model perform when you did real-world testing? Then how has working on this AI project contributed to your personal growth and development of technical skills? What new knowledge or skills have you acquired? So provide not more than 200 words reflection on this. So remember, as always, put this under your practical 6 after answering and solving your model with the link. Put everything under the page practical 6 on your site. Okay, just copy the text and paste it there. Then you will also be required to submit the text on a Google form that will be provided when the newsletter comes out. And please note that we will attempt to use AI to mark and provide feedback for this particular exercise. In summary, we have looked at what no-code artificial intelligence is, we have looked at machine learning concepts, and we have done a practical task. I hope you have found this informative. Thank you.